Okay, so now we're going to rationalize the denominator of higher roots. So as a quick example, remember if we took the square root of 2 over the square root of 3. In order to rationalize the denominator, you would have multiplied by root 3 over root 3. This is because 3 times 3 gives us the square root of 9. Oh, and then, of course, the square root of 6 on top. We know that the square root of 9 is 3. And we're just going to have the square root of 6 on top. The reason we do this whole rationalizing process is first to get this radical out of our denominator. But the reason we multiply by our denominator is because I know to get a whole number square root, you have to have the same number twice. So I took 3 times 3. So essentially, my whole number square root is going to be 3. So this process gets a little bit more complicated when we're talking about higher degree roots. So if we want to take the cube root of 3 over the cube root of 2, now when we rationalize the denominator, we have to multiply by a different number. I need to have some number that's going to get a whole number cube root in my denominator. So the most common mistake would be taking the cube root of 2 over the cube root of 2. If we did that, we would end up with the cube root of 6 over the cube root of 4. Now the issue with this is I still don't have an even whole number, not an even, sorry, I still don't have a whole number cube root of 4. So that's not going to work. Okay, I can't do the cube root of just 2. But if we think back to our process, we wanted to multiply by the same thing twice because that gives us a whole number square root. So what if I multiplied by the same number 3 times? Meaning, what if I change this into a square? That would be 2 times 2 times 2. Okay, so now we'd have the cube root of, let's see, 2 squared is 4 times 3 is 12. And 2 times 2 times 2 would be 8, or 2 squared is 4 times 2 is 8. Do I have a whole number cube root of 8? I sure do. That number is 2. I cannot simplify the cube root of 12 at all. My lowest even cube or perfect cube is an 8, and 8 does not go evenly into 12. So I'm not going to be able to simplify this at all. So I would leave it as the cube root of 12 over the cube root of 2. Okay, so now if we are thinking, if we're thinking about doing this same process for the fourth root of 5 over fourth root of 4. Again, I have to multiply by some number that's a fourth root, in which I can take the fourth root of the bottom and get a whole number. So the same process over here, we did 2 times 2 times 2. So essentially, we took the kind of cube it was, or the kind of root it was. We went down a number and took that number to that number. That was a lot of that numbers. Okay, so the kind of root or the index, it was a cube root. So we took this number to the power of the root minus 1. So instead of 3, we subtracted 1 and took a square. This number with the bottom. You essentially have to take one less of the kind of root. So again, it's going to be a 4. We know it has to be a 4, but to what power? So we take the outside number, which is 4 minus 1, gives us 3. This essentially is 4 times 4 times 4 times 4. Okay? So when we take that, 5 times 4 to the third is going to give us 320. 4 times 4 times 4 times 4 times 4 is essentially the same thing as saying 4 to the fourth. Okay, once we start getting large numbers like this, you don't have to keep multiplying out that denominator. This would have been the same thing as saying 2 cubed. Okay, 4 power and fourth root cancel. to give us 4 in our denominator. But then we have to say, go back to the last honors topic. Can I simplify the 4th root of 320 at all? So think about our whole number 4th roots. 2 times 2 times 2 times 2 would be 16. 3 to the 4th. Sorry, my dog's behind me. Is going to be 81. I don't know the 4th root or the 4th of this will help us at all. 256. That one's not going to help us. No. So we want to say, is 320 divisible by 16? So 320 divided by 16 gives us 20. So what about, is it divisible by 81? That is a no-go. So 81's out, 256 is out. 16 and 20 are going to be our factors. So we go ahead and we take this, the 4th root of 16 times the 4th root of 20. Remember, when we're doing these, we always simplify down as much as we possibly can. The 4th root of 16 is 2 times 4th root 20 all over 4. So our very last step here, 2 over 4 simplifies down to 1/2. So we will instead have the 4th root of 20 all over 2. All right. Again, if you have any questions on these, please let me know. I can get you some practice problems if you want to try those out. Otherwise, thank you. Oh, that was awkward. I thought it stopped. Bye.